Okay, hello. I'm Valerie Polichar. I'm the Senior Director of Academic Technology Services here at UC San Diego. And this is Adam Tilghman. He's our Senior Architect and Analyst for Academic Technology Services. And we're going to talk to you about our poorly named, but, oh, is that not coming up? It is not coming up. Where's that little button? This is the one we tried before. Okay, thank you. Our poorly named but descriptive data science and machine learning platform for students, which we call the DSMLP, which is very hard to say correctly several times in a row. So this really was inspired by the PRP and the Chase CI project. Larry and Tom, as you all know, had put this novel low-cost GPU cluster into action, the Fiona box, as it was known at the time. And Larry came to us and said, can UC San Diego put something like this in the hands of our graduate students? Now, when IT goes out to build something, when an IT department on a campus does this, very frequently we go to a vendor and we say, could you build us a system that does X, Y, and Z? And that's great. It's a very familiar process. We know how to do it. We have our vendors that we're used to working with. We get a fixed level of hardware and maybe even software support, and it's all kind of a known quantity. But when you're asking us to do something innovative, this is not necessarily the best way to go. It's expensive. That was one of the attractions of the whole Fiona model. Those vendors may not be ready to provide us with what our faculty and students need if we want something really cutting edge. And we're going to be limited by that vendor's expertise in what is probably a novel field. And we're also missing out because we've got a whole campus full of brilliant minds who are developing and innovating and coming up with new approaches every day, and we're not listening to them. So if we can learn from our researchers, which is really what Larry was challenging us to do, we can embrace that cutting edge and we can create something that's very efficient. We have on-campus expertise that we can leverage, and we did leverage. And we had a group of folks in Tom's lab that we could share experiences with and troubleshoot problems as we were getting this up and going. Now, the standard response to this from most CIOs has been, we don't usually do things this way. And you're going to have to design your own. It's not cookie cutter. It's not out of the box. And what about the fact that there's no 4-hour replacement support contract? When this breaks, you're going to have to fix it yourself. Now, enterprise IT does tend to build things with a lower risk on that basis, but which are less cutting edge. I was going to say that research and instructional IT has a higher tolerance for risk, but it's really, as Adam reminded me, it's really because there's a trade-off, because we can get greater capacity, more cutting edge, more out of that equipment by taking that risk. And for most of our faculty and students, that is worthwhile. So we did accept the challenge because our CIO, Vince Kellen, is a little bit more forward-thinking than just we're going to buy it from the vendor, whatever they have on the shelf. And we scrounged up some cash. We sort of looked at maybe money we hadn't spent that year yet and what we could pull aside and found $75,000, which is not nothing, but it's modest for what we were trying to do. And Adam architected our DSMLP on the Fiona design, along the Fiona design specs, and we rolled it out in September. And we started out with 10, not just graduate, but also undergraduate classes. And you'll see shortly how much that has grown. But I wanted to mention, I know we're here to talk about instruction, but we also added some access in 2019 for our students who are doing independent study projects. And also the beginnings of a baby research cluster for our entry-level research needs, we have it with San Diego Supercomputer Center. We have a lot of great offerings for people who know what they want, are ready to go, and have larger needs. But we didn't have a good option for researchers, especially in underrepresented fields, who might not even be a grant-supported field, but who want to dip their toe in the waters of machine learning. And if you want to hear more about the research cluster side of things, Claire Mizumoto is here, and I'm sure she'd be happy to share about that part of it. So the system has grown. We've grown it a little bit every year, and we've basically never had a budget line for this. Every year we kind of save dollars from other areas because we want to prioritize student learning, and have managed to scrape together enough to build quite an impressive system that now has 72,000 student enrollments in that period of time. 620 classes have been offered. 170 instructors have touched this system in all 9 divisions, which that is, to me, the really exciting part. We're getting somewhere between, I'm going to say 7,000 and 10,000 unique students a year. It varies a little year to year. But we're touching a lot of UC San Diego's student body. Now, part of what makes us able to support all these different disciplines is that we offer a variety of choices for our faculty. So Jupyter Notebooks, as Larry said, it's the easy button. This is something where maybe it's not a traditional computing discipline, maybe it's public health, or maybe it's music, or maybe it's history, that they have ways to set up a structure for their students to actually work with GPU power, but without having to build it from the ground up. We also have computer engineering classes who are heavy users of the system. They're going to want shell accounts. They're going to want to be able to do much more complex machine learning workflows. So we allow them to come in with their terminal logins and a full development suite. We also allow our instructors to install their own library packages that they might need, or even build their own custom Docker container. So we can meet the needs of a large range of disciplines. And the big takeaway is that our students have training available in every single division in many different disciplines, in skills to perform, design, build, machine learning, and/or data science, whatever's appropriate for their particular field. Means not just our engineering students, but all our students go off into a competitive job market with really high-level skills. You know, if you go out into public health today and you have the ability to work with these kinds of data science tools, you're a step ahead of the folks that just have Excel in their back pocket, right? Every one of these fields, it gives them an edge, so not just engineering. And in fact, of course, our students who are going to go on to higher learning are also walking in there with a much more sophisticated toolkit. So to me, this is the big exciting aspect, is that we're enabling our students to really be competitive. And this is an eye chart. I think it's a little hard to see the exact numbers, but what I want you to see is just, first of all, there's a huge trajectory upwards of the number of students that are using this every year. And those colors are the different divisions. Some of them are a little smaller, right? Arts and humanities is that light purple color, and you don't see it every single quarter, but they are definitely making use of this. Obviously, School of Engineering, which is the green, pale green, is using it a lot. But some places that surprised me at first to see how much social sciences are using the cluster, how much our professional schools are starting to work with it. I think that's primarily the business school. And so everybody's touched it a little bit. And I think this is where I pass it over to you.
All right. And I just want to give you a little bit of a sense for why we think that trend is going to continue. This is another list of classes similar to the one that Frank showed yesterday, but this is what we've got this quarter. The classes that are machine learning oriented are in blue. So you can see there's a fair representation of machine learning, but also a decent number of classes that are just in there for the Jupyter environment. We see quite a number of classes that do not tick off our GPU machine learning enablement button. But the other thing I want to show you is that these classes are from all over campus. And so we've got music, we've got political science asking for GPUs, that's new. I don't want to know what they're going to do with it. But I think this emphasizes the spread into those other disciplines. We've had a steady body of courses running within computer science, data science, electrical engineering, et cetera. That's been our core. And I think we might start to see a little bit of slowdown in the growth there. But I think we're just at the beginning of the curve for these other disciplines. Right now, we've got 2 courses in music that are using machine learning and Jupyter environments. But looking through their course catalog, I see 10 more that could. And I think as they become more familiar with these tools and more comfortable working in these environments, I think that that graph, if we look forward into the next 5 years, will continue pointing upward. I'm going to just take a very short minute and describe how this system is architected. As Valerie mentioned, this is based very closely on the Nautilus and NRP architecture, but we adapted it to fit our local IT capabilities. We had people that were already Linux sysadmins. They were not Kubernetes sysadmins. And so we opted to use fairly traditional NFS-based storage for our students rather than adopting something maybe higher performance or more scalable. For coursework, NFS has worked out just fine, and it allows us to align what people do within this environment with what they do on a desktop or in a maybe on one of our shell remote access Linux systems. It's a common data presentation that all the students and all the faculty are really comfortable with. We give each student a namespace, very similar to NRP, and that helps isolate their environment. We can set quotas. We can give a student who really needs a couple of GPUs and maybe 100 CPU cores and half a terabyte of RAM. We can do that when needed, but we can also constrain what an intro to data science student gets to be more appropriate to their coursework, maybe 4 CPU cores and 8 gigabytes of RAM. And then that flexibility also allows us to support those independent study requests that Valerie mentioned, where we have undergraduate capstones, masters, and then even a few PhD students with the help of Claire Mizumoto's team are in and doing their work and able to really take advantage of any of the resources that we've got. We've only got 132 GPUs as we've been purchasing them in bits and pieces over the years, a wide variety. But lately, we have been, and this is mostly having to do with NVIDIA's market dominance. We've stopped buying the game cards as much because they are harder to support. And I'm really hoping that we can get back to them, maybe with Tom's help, get back to buying those. They certainly are much more cost effective than the enterprise models. So in addition to all of that hardware that we have bought personally, in the last 6 months or so, it seems like pallets of server hardware have been dropping out of the atmosphere onto us. Because this environment, we also leveraged this environment because it was Kubernetes and because we had experience standing up machine learning stacks, CUDA, working with GPUs. This was a natural place to pilot our LLM, our campus-facing LLM. That's what Vince Cullen talked about yesterday. And with that came some fairly potent hardware. We've got 24 H100 GPUs and that are currently mostly sitting idle. And so my task for the next term is to figure out how to get those in the hands of students. That may not be sustainable. That may be, this may be a 1 or a 2 quarter opportunity that we have. But I think we've got the structure in place to allow them to do it if we can find some students that do want. So if any of you are here at UCSD and have students that are looking for H100s for a project, thesis project or capstone or something like that, please reach out to us. I would love to see something interesting happen there.
Why do you only have them for a short period of time?
Well, because if Triton GPT takes off, it will, but it's possible that we may go back to kind of getting on the mainframe during evening hours sort of model. We'll see. Yep. Yep. And for those of you that are interested, this is what our full 2 racks looks like. Space, I mean, a lot of us are being challenged with server room space. We are too. And so I think if we're going to grow any further, we're going to have to go find another rack. But a lot of those, every one of those 2Us is a Fiona box modeled right off of what John Graham had specified. So we're really indebted to all the work under Tom's area. This has not cost us a lot of money. We're talking $75,000, $80,000 a year, and as Valerie said, that's mostly leftover money. And so we've been buying what we can and expanding when we can, but we've now reached the point. We've got some of those initial Fiona boxes are 8 years old, and they are starting to experience failures. And so we've gotten to the point where we're going to have to start using that $75,000 a year to replace that initial hardware. And that's going to present a challenge if we continue to see the growth that we anticipate. And so I think for us in the next year or so here at UCSD, that's going to be a subject of discussion to figure out: do we stop here? Do we find a way to continue that growth? And maybe some sort of collaboration with Triton GPT is the way to go, or collaboration with NRP. And lastly, I just want to show a similar graph. I didn't quite get the color scheme right, but this is what the DSMLP CPU and GPU usage has been like for the last 6 months. And so we've had about 170,000 GPU hours. I think that's on par with some of the larger namespaces, but the DSMLP could fit comfortably within NRP, I think, but as a large tenant. But we certainly do see, you can see the disparity between the GPU hours and the CPU hours. I take that as an indication of just how many people are in there only to run a Jupyter notebook. All they want is a place to compute and run some Python. And so I think even if you don't have the resources to stand up something like this, either adding hardware to NRP or on your own, I think just taking this model as a CPU-only enclave would be a very valuable addition to most any institution. That 4 million CPU hours, that's about $150,000 of Amazon time over the last 6 months. And so you can buy a fair amount of hardware with that amount of money. And I think we have I think there's a long history within NRP and PRP and our DSMLP of showing that that on-prem high utilization model works. And so for that, really, thank you, Tom. Thank you, Larry, for kind of championing that. And then I'll hand it back to Valerie, who can speak to one last angle, which is how do we run this?
Yeah, folks are always say, well, how many folks did you have to hire to run this? And we didn't actually hire anybody, although that was a little bit painful. We started out, I would say 100% Atom and scrounged sysadmin and engineers from our department. We now have 4.5 FTE, I would say roughly, that are devoted to the project. And a team of 5 student staff who, again, we came up with some funding in our department. This group of folks had not had student staff in many, many years. And we thought this would be an opportunity for the students as well as for us, and it has worked out very much that way. We get students, sometimes they stay with us about a year or two usually, very often going straight on from working with DSMLP to getting a position in industry where they can use those skills. So it's yet another way to bring the students in, get them involved, and get some assistance as well in running this. I think that is it for us. Are we taking questions in between, or are we going on?
Let's take questions at the end.
Okay.
Or actually, let's take a question while he's setting up. There we go.
The mic live, please. Great. Okay, so I just wanted to say that going back into time, I get credit for a lot of this stuff, and part of it is because my job in the world is to explain Larry to the world and the world to Larry in this world anyway. And so it was me explaining John and Dima to Larry so he could do these things. So Dima and John are really the people who did all this stuff. Now, Adam convinced me it was real. I didn't believe it until Adam said, well, I just did it, and we set all this stuff up, and it works, you know. So I didn't believe that it was really going to work and be able to expand until you did it, Adam. So congratulations. And John and Dima, you don't get credit enough, except for everybody knows to ask you, John and Dima, on Matrix, because you have the answers. I don't have the answers, right? I only got the proposals, so thank you.